for rooms that have huge openings, you have a big opening here, big opening, you just want to have a luxury living. In that case, you'd still require columns where necessary. So does that mean that there are no situations where you can't have pillars? You can. Is it possible for you to do a house without pillars completely? And up to what? Up to what level? 3 or 4 floors? Say if you are doing 3 floors. Yes, it is possible not to do columns. So 1, assuming your ground is okay, stable. Number 2, your terrain is good enough. Number 3, you are using the conventional method that is the masonry that are of good quality. Number 4, your spaces, your openings are not so big. When I talk about opening, I'm talking about you have a door or an arc that is so big, or you have an open plan sitting living room, an open plan kitchen, that where the wall, the support here, there is a big distance. So that case, you need to incorporate some pillars in some places. But if you have a bit compact of your building, then in that case you may not necessarily, and that matter you have them good blocks, good building blocks, and your ground is good. Yeah, you can it's possible to omit columns. Again, columns help in overcoming okay, let me come again. Columns help in protecting the house against any lateral load that can arise. When I talk about lateral load, I am talking about, say for example, there is some strong wind, very strong wind that has an effect on the building, because stones do not have good strength or towards to resist horizontal forces. So horizontal forces like wind, like earthquake, if at all your area is also not stable, maybe strong winds, very strong winds, or you have earthquakes, there is cases of earthquakes, then it is also important to have columns. But if those are not present and you do not foresee that, and all other parameters that I've talked about before and are well taken care of, then it is possible not to have columns. Let me see whether I've answered that question. And but if you are going beyond 3 floors, or even from 3 floors, I would really encourage you to include columns. So let me say, not really as a rule of thumb, from 3 floors upwards. Of course, you don't start the columns there. Talking about if your building has more than 3 floors, then have columns, because the stones have a limitation in terms of strength that they can be able to hold. So columns now come to supplement the capability that the stones have. Then, how durable are the houses made of alternative technology? How long do they last? Well, depends. It also depends the technology. As I talked about interlocking soil blocks, the interlocking soil stabilized blocks, the Makiga. Some of them were not able to last for long. You can see some houses done on those interlocking soil blocks looking so old, and you can't believe that it was done less than 10 years ago. But ordinarily, a well done house with EPS, with precast panel and any other technology, it will last for long, and especially if it has been done right, including the interlocking soil stabilized blocks. So it is as durable as the conventional. That will be my response. Now, I was to talk about the slabs. I was also to talk about the slabs, and after I've talked about the walls, what are some of the alternatives that we have for the slab? Now, that now ties into what Nancy had asked about beam and block. So the conventional. What has been the conventional for the slabs? The conventional for the slab has been what we call a reinforced concrete slab. What do I mean? A reinforced concrete slab is a slab. The slab is the one that we are stepping on. It's a slab that is made of concrete. Well, I want to believe that we all know concrete, which is a mixture of ballast, cement, and sand. So it is concrete that has chuma inside. So the chuma help to strengthen the concrete. And that's why it's called reinforced. Reinforced is to strengthen. So it is a concrete that has been strengthened with reinforcement bars or the chumas. So that has been the ordinary, and I will call it the reinforced concrete slab. Now, again, the cost of chuma, the cost of rebars, the reinforcement bars, the chuma, the cost has been increasing. What the cost was some years back has almost doubled. In fact, it has doubled, depending on the year. More than 10 years ago, the cost has more than doubled. The cost of rebars has more than doubled. The chuma that you would buy at around 300 more than 10 years ago is now being bought at around 700 shillings. Okay? So that tells you that the cost of construction, that has had a big effect on the cost of construction. And slabs, especially the slabs that are hanging somewhere, they are suspended, like the first floor, the second floor, or even if at all the ground floor has been, what I talked about, suspended. If that be the case, then people are looking for ways to save money. The cost of cement has also been increasing. So the question is, how can I navigate and do my slab cheaply or in a way that is affordable? So that has brought the conversation to seeking out other alternatives as far as the slab is concerned. So I'll mention a few technologies that have come up as far as the slab is concerned. Number one, other than what we called the reinforced concrete slab, the ordinary, the conventional one, now we have what we call the beam and block. And then we also have the EPS slabs and so on and so forth. There are of course several other technologies. I would also mention of hollow pots, hollow concrete pots, or hollow slab, or hollow, what do we call it? Hollow pot slabs or ribbed slabs, or all those technologies. Now, one of the oldest technologies that have been employed as far as the slab is concerned is what we call the waffle slabs. I'm not sure whether my listener, you know the waffle slab, but they have been very old. You've gone to a house and it has some holes on the ceiling. It has some holes, some box like, that has been made of the waffle slabs. They are very old as far as I know. I mean, they have been there for quite some time. But again, some of the technologies that are gaining traction over time. One I'll talk about the beam and block, and there are two types of beam and block. We'll talk about them, and the other one is EPS and also the hollow pot. So the hollow blocks is whereby we have blocks that are hollow, that are laid in rows, and in between each row there is a gap where we put reinforcement bars, and then we come and pour concrete. But above the blocks we have a BRC, a mesh fabric, and then you do concrete on top of that. So the amount of concrete that is required for the hollow pot is less than the amount of concrete that you'd require for the ordinary, the conventional. So that would translate to kind of a saving on the part of cement. Again, for this, the amount of reinforcement that is required for the hollow pot is less than the ordinary. So that also a saving on the part of reinforcement. But again, this has also not, you also need to remember that there is an added cost of the blocks. there's an added cost of the blocks, and that has to be put into perspective when you are looking at the cost of the hollow pot vis-a-vis the conventional. Right. So having talked about the hollow pots, the second one, which is the EPS. Again, you remember I talked about the EPS, the expanded polystyrene. Now this one now for the slab is the same, that has some shape. It has some shape, and then the shape, you would have some gaps, just like hollow pot. We will have some gaps where you put the reinforcement, and then it has a mesh. That one comes with a mesh, and then you pour concrete. So it behaves more or less the same as the hollow pot. And as I talk about the slab, I forgot to mention something on the walls. Let me just mention this in passing about bricks. Bricks is also one of the technologies that have been used. They are clay-fired bricks that have been used before for long. And one of the good thing about bricks is how they give you a good finish. It gives you a good impression. There's some, the aesthetics are well taken care of. So about the slabs again, let me come back to the slabs. The second item that I was talking about was the EPS technology, and then I also mentioned about the beam and block, and I said that there are two types of beam and block. The first one, we normally call it the T beam and block, and the second one is the flat beam and block. The T beam and block, or the beam and block technology, is where you have a small beam. There's a small, on the slab, you have a series of a beam, like a small beam, and a layer of blocks. Where you would put, in the hollow pot, where you would put the chuma, is replaced with a beam, a small beam. That is a precast concrete beam. And then you have another layer of hollow blocks. Then a beam, another line of hollow blocks. So it also behaves the same way as the hollow pot slab, but in this case, the amount of concrete is greatly reduced. When you buy the beam and block, you do not need to buy the chuma that you put between the blocks. The only thing you buy is the mesh fabric at the top. So for both beam, both the T-beam and the flat beam and block, you only need BRC mesh and a thin layer of concrete, and that is it. You do not now buy the normal chuma. So that technology saves you from the headache of knowing the prices of reinforcements for the slab. You don't need to buy the D10, the D8 for the slab. You'll only be concerned with the reinforcement for the beam. Again, there's a video that I've talked about the two aspects of beam and block, the flat beam and block and the T beam and block. And the question was, how does that is there a saving? Again, also depends with the availability of the materials. For the concrete, you need to know, is my sand, how much is the sand, how much is the ballast, how much is the chuma around me, because I'm a place where I can get this bought cheaply, then I can just go ahead and do the conventional. But if at all the cost is significantly high, then you need to explore what are the cost per square meter for each. Well, again, the cost difference isn't as much. There are some technologies that would give you some saving depending with the place. Yeah, depending with the place. So indirect benefits for the beam and block and the hollow pot, because of the underneath of the slab is a bit rough, then the plastering is easy. Doing the plastering on the ceiling is easy, as compared to the slab. The normal slab you'll have to hack. Again, that's a small cost that is involved. How durable is it? How safe is it? I only have concern with the hollow pot, because in the industry I've seen people who are doing some funny things as far as hollow pot is concerned. So I'd want to give a caution on the hollow pot, that you may need guidance from a professional. It needs to be done professionally, otherwise it is easy to mess with the hollow pot. But for the EPS, for the beam and block, most of the manufacturers that I know, they give you direction. They have to come and do a design for you and tell you this is what you're going to put, and this is the chuma that you're going to put for that matter, and that becomes easy for you. So caution on the hollow pot, but the others, it is well taken care of. Now I can see we are moving on well. Let me see if at all you could be having any other question. Okay, so for the roofing type, we talked about 3 types of roofing. We have the normal roofing, the mabati, be it decra, be it the shingles, be it, there are several kind of roof coverings that can be done. The clay tiles that can be done for the normal roofing. The normal roofing is what the question was asking about, the hipped roof, the roof that has a shape, okay? And it has mabati or decra or any other material above it. So ordinarily, this roof for normal houses, you'd require that covering. That's the roof covering. You'd also require a structure for it. And that structure would be made of timber. So it comprises of timber trusses, the rafters, purlins. Those are terms that are in the construction industry. So to do that roof, you require the structure. In many cases, you would have the structure done with timber, and then you do the covering. And maybe there could be some accessories that are needed before you do the covering. Maybe like some sheets or buttons, depending on the type of roof covering that you are doing. Now, the second one is what we have known as the flat roof. The flat roof is where you do not do the roof covering, but instead you do a slab at the top. I've seen this work so well with houses that are a bit square in shape. Again, it's a matter of preference. There are people who love the ordinary roof covering. There are others who love the flat roof covering. It's a matter of preference, and the shape, the concept that you want to go by, right? So it's a matter of preference, and because of the cost implication of the flat roof, because sometimes I find the flat roof, since this is an ordinary slab, and the changing cost of materials, the cement and the chuma, to be specific, vis-a-vis the normal roof, where you can be able to use ordinary mabati. If you are using ordinary mabati, you have your cost of normal roofing vis-a-vis the flat roof, there is a big difference. So if you do the roofing with the ordinary mabati, you find that your roof will be cheaper than doing with flat roof. But there are also other materials that you can use for the roofing that now make the cost to be higher than the flat roof, or to be the same. So there are people who would prefer to do flat roof. They love the design that has a flat roof, but you don't want to go the extra mile of doing the slab. So you resort to do the normal roof, but this roof is gently sloped with ordinary mabati because they are not going to be seen, and then you do a walling around it that now creates an impression of a flat roof. So this new approach or this new concept is what we call it, or has been called, the hidden roof. So it's a normal roof. It's a normal roof that looks like a flat roof. Okay, so that is the hidden roof. So it's a third alternative. So why many would go for that is because, one, the hidden roof would be cheaper than the slab, the flat roof. Yet it ends up looking the same as the flat roof. Secondly, as compared to the normal roof, again, it will be cheaper in the sense, in my view, it will be cheaper in the sense of the structure. Remember that for the ordinary roof, the slope is the slope is bigger. There's a bigger slope. The slope is more steeper with the normal roof as compared to the hidden roof. Okay, so because of that, then you find that the materials that would be required, both to do the roofing structure and also for the roof covering, also vary. So you require, for the same area, you would require more material for a normal roof vis-a-vis for a hidden roof. So there is a saving there. That makes now the hidden roof more cheaper. I would say it's even way more cheaper than the two. Okay, not way more cheaper. I think I should not use the word way. I should say it's cheaper. Again, remember, you'll have to do some courses of stone. And the one key implication that you need to know with the hidden roof is that you require a gutter. You'd require a gutter to drain off the water, and that gutter is done on the inside. So that is the one cost implication that would not be necessary with the normal roof, because for the normal roof you can do the plastic gutters, but for this one you do a gutter on the inside, and many to be done with concrete. So that increases the cost of the hidden roof. But at the end of the day, you have the privilege of using ordinary mabati for the hidden roof vis-a-vis for the normal roof, because for the normal roof the mabati will be seen, but for the hidden roof the mabati is not seen. Right, I think with that, I don't know whether we have other questions, but I want to believe that we have been able to touch base properly on the alternative technologies and the different professionals that are involved, the journey of home ownership, the requirements to approval. Yeah, so I guess your question, Jacob, on the roof technology has been answered. David, your question touching on the cotton and also touching on the columns has also been answered. Nancy, your question on the beam and block, and Mihaki on the precast wall panels, I want to believe that has been answered. Right, okay, sawa. So I think that is it for today. I'm glad that we were able to touch base. We are looking forward to having more of these live sessions where you can be able to ask your questions and we answer them as we move along. We'll be able to let you know when we'll be going again live. We would want to, our desire this year is to be able to help you to build smart, to avoid mistakes, those costly mistakes. I mentioned that the cost of construction is high. It's high. So to avoid the costly mistakes that are in construction, how do you avoid the conmen? How are you become aware that there are, the pitfalls and how to avoid them? What alternatives can you take? How are you able to just generally build smart and with ease and with confidence? That is our perspective for this year, for you. So kindly, let's continue to tune in. Let's continue to join. I know there's still more about these mistakes. There's still more touching on how do you plan, how do you read a drawing plan, how do you estimate the cost of a building. All those would be very important. So that is it for today. Once again, this is the Building Consultants Show, where we seek to educate, challenge, and inspire you on your journey of construction. Kindly let's continue to tune in, subscribe if you have not subscribed, and also share to your friends, to your neighbors who are desiring to do construction.